All right. Okay. All right, I'm venam, and I'm gonna present what does it take to resolve a host name. Resolving a domain name is complex. It's not limited to the DNS, the domain name system, a decentralized and hierarchical system to associate names and other information to IP addresses. It's not something we as users usually pay attention to. We notice it only when we're facing an issue. It normally works out of the box, but really nobody gets the crux. You search online for clarification, but they barely help and add more confusion. Here are some schemas trying to decipher the mystery that domain name came to be. 1, 2, 3, I think you get me. It's not easy. It's never as simple as taking a host name as a string, getting the DNS address and the etc resolve conf config, then sending a request to the DNS on port 53 to be greeted back with the IP. Behind the scene, there's a ton of files and libraries involved, all of this to get the domain name solved. So in this talk, we'll try to create some order, to try and understand things as an end user. Let's make sense and reason behind this mess, even if I have to say, I don't get it much myself. I can't assess I haven't made mistakes, but if I did, please correct me, that would be great. So let's start with the misfits, the one that don't follow the rules, the not invented here syndrome found within our tools. When it comes to DNS resolution, there's no one-size-fits-all solution. Obviously, many of us don't want to deal with all the complexity, so we say, let's pack these bytes ourselves and forget the hassle. That's pure heresy, though. We'd prefer everything to work the same way so that it's easier to follow. It would be preferable that they all use the same lib, to all have the same behavior. That is, in our case, to rely on the C standard lib or the POSIX API, our savior. In all cases, let's note some software that don't rely on it. As we said, all the misfits. The ISC/BSD bind tools, from host to dig to drill to NSLOOKUP and more, used for debugging cores. The browsers, because they are one of a kind, bypassing libc and POSIX mechanisms, because they implement their own DNS API for performance reasons and perfectionism. Any other application needing advanced DNS features other than simple name to IP, and language that don't wrap around libc. The Go programming language comes to mind. It implements its own resolver API. Fortunately, I can ease your mind by letting you know that all these will at least respect etc resolve conf and etc host configuration files that we'll see in the next section. I've taken a look at a dozen different technologies, and I think the best way to understand them is through their archaeologies. There's a lot that can be explained about DNS resolution simply based on all the historic reasons. The main thing you need to understand is that there's not a single clean library call to resolve a hostname. Standards and new specs have piled up over the years, with some software that haven't followed but risking to disappear. Overall, libc and POSIX provide multiple resolution APIs. There's the historic low-level one provided by ISC/BSD bind resolver implementation within libc, accessed through libresolve incantation. There's the get host by name 3 and related functions implementing an obsolete POSIX specification. There's finally the get address info 3, that is the modern C POSIX API for name resolution. All these combinations, ladies and gentlemen, are the standard way to resolve a name. Newer applications will use get address info, while older ones will use get host by name. Both of these two will often rely on something called NSS and another part to manage resolve.conf access. Now let's dive into each of these and you'll get them like a breeze. The resolver layer is the oldest and most stable in our quest. It originates from 1983, today almost 37 years ago, at Berkeley University. It comes from a project called BIND, Berkeley Internet Name Domain, which was sponsored by DARPA grants. And like the Berkeley socket that gave rise to the internet, it has now turned into much pain. It was the first implementation of the DNS specification. It got released in BSD 4.3, and today the BIND project is maintained by the Internet System Consortium, aka ISC. It not only offers servers and clients and the debug tools, which we mentioned earlier, but also offers a library called libbind. This library is the de facto implementation, the standard resolver, the one of a kind. It is initially based on all the original RFC discussions, namely RFC 881, 882, and 883. The BSD people wrote technical papers assessing its feasibility and went on recommending and implementing it within BSD. At that point, bind wasn't the standard yet. It was an optionally compiled code for those who wanted to get their feet wet, those who wanted to try DNS. Then it got part of the C standard library interface through resolver or libresolve, resolve.h. If you take a look at most Unix systems today, or Unix-like system, macOS, OpenBSD, Linux, and company, you'll see clearly in resolve.h the copyright going back to 1983, to that very date. But obviously it depends on the choice of the implementers, case by case. So then the code diverged. There's the libresolve provided by the C standardization and the libbind provided by the bind implementation. However, most Unix only add small specific changes to their needs. For example, resolver and glibc is baseline of libbind from bind version 8.2.3. This layer is normally used for low-level DNS interactions because it's missing the goodies we'll see in this presentation. Now let's talk about the environments and configuration. Obviously, there's the resolver configuration, this particular file being etc resolve conf. You'll see it hard-coded in resolve.h, and if that file is missing, it will fall back to the local host as the DNS, just to be safe. Additionally, there's etc host.conf. According to the man page, it's also called the resolver configuration file. It's so appropriately named, I know. It's a conf that dictates the working of etc hosts, the static table lookup for host name. So what's in these files? Resolve.conf takes care of how to resolve names and which name server to use for that, while host simply has a list of known host aliases, IP plus name. So it's as simple as that. Within resolve.conf, you can also have a search list for domain. That's if a name you're searching for doesn't have a minimum number of dots in it, literal dots in it, then it will add one of these TLD to it, top-level domain, and it will keep searching until it finds something that fits. This can also be manipulated through environment variables like local domain. There can be a sort list of IP net masks for when there are many results to match, but you don't want to give priority to the cloud VPS that lives only for cache. There's finally the option field, also overridden the command line by res option environment variable. It manipulates what's the minimum number of dots to search, and also if you want to set the debug as enabled. Meanwhile, the host file is but a key value DB, simply made of domain name and IPs. So remember that all of these are mostly used everywhere because it's the lowest layer. So it's used by libbind and libresolve, but also the custom NIH syndrome. All right, so far that's all the classic clean stuff. Let's move on to the next section. You'll scratch your head until there's no dandruff. The C library POSIX specs create a superset over the C standard library. They add a few simpler calls to resolve hostname and make it easy. These focus on returning A and quadruple A records only, IPv6 and IPv4 and IPv6 respectively. There's the get host by name 3, which is deprecated, and there's the newer get address info 3 defined in IEEE 2000, which mainly adds RFC 3493, aka IPv6 is now supported, basically. So applications are recommended to use this updated version unless they want to divert from main lane or whatever. There are functions to resolve IP address to hostname, but in this presentation, let's focus on IP today. I know it's late. Apart from IPv6 support being added, some internal structures have been updated, as they weren't so safe between subsequent call and thus could be your demise and your fault. Obviously, they also both return different structures. Some libc implementation will get fancy and add their own modified version of get host by name. For instance, in glibc, they add support for IPv6 and their modified get host by name 2 for backward compatibility. Regarding configuration file, get address info will use etcgay.conf, which takes care of precedence of addresses returned, which address is used before the other. Now you're going to brandish your torch and yell at me, but Resolver 3 already does that by default. Well, I let you know that Resolver 3 is only interested in DNS calls only, while these two POSIX functions and their egocentrism are mostly interested in all the ways files and mechanism that a name can be converted to an IP. That is, they often rely on something called NSS, which is what we'll see in the next analysis. Both get host by name 3 and get address info 3 will most likely rely on the NSS service. But what is NSS, aka name service switch? First of all, it is not to be confused with network security service, which has the same acronym but has a library called libnss. In our case, it's libnetdb, not libnss, with a netdb.h header. So keep this in mind for later. To understand what NSS is, we again have to go back in time, back when the tech was still in its prime. There always has been the idea of sharing configurations between machines. However, back in the day, it was all hard-coded with the exception of Ultrix. Hard-coded in files like aliases for email, etc host for local domain, the finger database, and all that it entails. This idea dates back for so long that netdb.h header was almost always there, but was looking at these files we mentioned earlier. From that point on, we needed something more flexible. And so Solaris OS said, let's not have it hard-coded. That's not acceptable. Let's create something called the yellow page, a sort of phone book for configuration brokerage. But the name yellow page had legal issues, so let's go with NIS for Network Information Service. Other Unises liked it. They liked what they were doing in their business. So they reproduced it in something called NSS, though NSS, Network Service Switch, is much simpler than this. Let's have a side note about OpenBSD, which doesn't implement NSS, but has a pseudo NIS, something called YPserve, the yellow page written by Theodorat from scratch, but he doesn't care about the legal name Wrath. So let's summarize. NSS is a client-server directory service protocol that has as a role to distribute system config between different computers to keep them harmonized. It's more flexible than fixed files and libc and POSIX, and is arguably like LDAP, or Zookeeper if you know it, or actually like any modern way to share configs between containers and microservices. But what does it have to do with domain names, you may ask? Well, a map of name with IP config like any other is the same task. That also includes things from host, password, port, aliases, and groups. Yep, it's quite the big soup. Apart from the functions in POSIX, there is a command line utility that goes by the name of getEnt that lets you access NSS facilities to do simple queries for its entries. We can obviously query for a host name, which is our game here. So how is NSS actually working? How does it also do the resolving? The NSS library consults a file called NSS switch, and there's a directory, the etc default NSS. And depending on the entries in it, it will sequentially attempt until it's satisfied, until it finds what it wants, until it got the demand. You'll find, for example, here at the bottom, host entry in this file, which is with strings on the right. These strings are the modules which will dynamically be loaded, sequentially executed, the format even allowing to have appended conditional rules. Like here, the unavailable return, I'm skipping the resolve plugin if it's not available on my machine. To get a list of all the NSS plugins and modules, you can look in your lib directory mess for anything that starts with libnss. The most common modules are the following: files, DNS, NIS, my hostname, and resolve for systemd, resolved. And there's a bunch of others in case you're in the mood to be a crusader. So let's open a parenthesis on the resolve plugin before you throw it quickly in the dustbin. It's quite advanced, having multiple features like caching, the NSSEC validation to resolve conf, as well as being an NSS plugin. And when it's used as an NSS plugin, you can communicate with it via dbus sockets. Otherwise, it always listens on port 53 for fallback in case you didn't use NSS. Now let's move to something else, something you haven't thought of yet. As we said, resolve conf is used by all these components, but not only them, also all network agents. They are also in charge of setting and changing the DNS address. Each of them, from DHCP client, PPP daemon, VPN manager, network manager, they all want the access to this file. And what about having two network connections concurrently, each requiring their own DNS, obviously? So everyone wants to use the resolve conf file, thus we need a manager to handle it. We want to avoid an inconsistent state in this file. It's vital to not let everyone mess with it, and that is what resolve conf 8 role is. Anyone wanting to change the resolve.conf should instead pass through the resolve conf to avoid the hassle. It does that by using its resolve conf command line executable. Similarly to the resolve.conf configuration, you can also pass anything to it like domain search and options. Now, resolve.conf is rarely a plain normal file itself because the manager finds it easier to create a symbolic link and avoid the abusiveness. the default implementation has it in /run resolve conf, a name of an interface resolve.conf. Accordingly, like any other tool, resolve.conf has a configuration file and etc resolve.conf and a directory with hooks. Within these files, you can mention if you want the symlink to be at another location. I'm saying default implementation because like anything else on a system, you can replace it with your own concoction. Two popular alternative solutions to this problem are OpenResolve and systemd resolved, which we mentioned earlier. So resolve.conf is rarely a file. It's more likely to be a symlink. And check all of these at the bottom, for example, and you'll be surprised, I think. And computers, you can make anything faster with another level of indirection. That's what all cache mechanisms try to offer, and domain name resolving is no exception. There are two places where caching is available, either through a local DNS proxy or through something called NSCD. Just remember that this last one isn't very stable. So let's start with NSCD, which is an NSS proxy. So it not only caches DNS queries, but also anything related to getting an NSS entry. The other caching method is to run your own local DNS server, be it bind9 or DNS cache or any other server or other resolver. These can either be full features, bells and whistle, or only provide a lightweight cache proxy if you're not feeling like you want to go into details. Another reason to run such servers would be to block ads and all their malice. Also, just be aware to flush the cache, otherwise you'll get surprises that will make you crash. I think I'll skip that, be on time. So let's conclude here. You should now be comfortable with anything in the domain name resolution sphere. It's all about shared config management like Zookeeper, LDAP, and these other arrangements. I hope you've learned a thing or two and that domain name resolution is less of a taboo. Thanks for listening. So if you have questions, you can put them in the chat. So ISC stands for Internet System Consortium. So it's like a group that makes the standard. So it used to be BSD. To go back to that point, so what does ISC stand for? So initially, the BSD guys got a grant to implement the IP and with the DNS. So they took a look at the specification and said, okay, we're going to implement it, and here's the problem, and here's how we're thinking to implement it, etc. It was in the RFC. So at that point, then POSIX took on. It was a superset. These days, it's not BSD anymore because it's not a group, a standard group. It's now another standard group for the internet called Internet System Consortium. So Internet System Consortium, they do also maintain bind, the default implementation of the DNS server, and also the libbind, the client library, which can be used for both the server and the client. So anything new in the specs, they're going to implement it first because they were the first to implement them and to also follow them. How to flush the NSS cache. So NSS cache is within NSCD. So if you're not running NSCD, you wouldn't have to flush the cache in NSCD. Now, I'm not sure if there's a command to flush NSCD itself. It's probably it's a daemon that runs, so maybe just restarting it would be enough. I'm not sure exactly of the specific, but just not running NSCD should be enough.